So, hello guys, with the name of God Ram Ram. Today, we are going to solve a very interesting problem. This problem was asked in Codeforces Division 1 plus 2 round 1018 1018, and the problem C. This is a dynamic programming on matrix problem, okay? And it's a very interesting problem. Many people were not able to solve it. So, guys, coming to the Jamboard, what they are saying is that we are giving you a n cross n matrix. We are giving you a n cross n matrix like this. You can also fill this matrix. I can also fill this matrix. Everything is going great. Everything is going well. Okay. So for n equal to 3, let's say they have given you this matrix. Okay. Uh, like before you watch this video, make sure you do my prerequisite dynamic programming course. I will attach the link to it in this document. The document link will be in the description. So make sure you watch it and then you come to this video. So because you should know dynamic programming in advance for this problem. Okay. Anyways, guys, so this n cross n matrix is given to us, right? They are saying no two adjacent cells should match. Any kind of adjacent cells should not match. So if let me take a lovely example for you. If this is your cell I comma j in the matrix, then it should not be equal to any cell above it. It should not be equal. The value should not be equal to any cell on the right hand side, any cell on the below, or any cell on the left hand side. The values should be all different. No, there should be no adjacency. There should be no adjacency, guys. When it comes about adjacency, there can be horizontal adjacency like this, and there can be vertical adjacency like this. No two adjacent cells should match. So if I give you this matrix, can you tell me, is this a good matrix or not? A good matrix is a matrix where no two adjacent cells are matching. Can you see here the two adjacent cells? I hope you understand the meaning of adjacent, consecutive. Either the consecutive cells can be like this, here 8 and here 8, or it can be like this, like a number here and same number vertically below. So two adjacent cells are matching. That's why this is a bad matrix. The question is saying that convert the bad matrix to good matrix. Convert the bad matrix to good matrix. Why this is bad? Because you can spot a place where the two adjacent cells are matching. So how will you convert it into a good matrix? They are saying that you can do a column operation or a row operation. But you can do a column operation at a particular index only one time. Like if you do a operation on the first column, the cost of doing that will be C1. Similarly, if you do operation on the second column, cost of doing that will be C2. If you do the operation on the third column, the cost of doing that will be C3. Like that, if you do operation on the first row, the cost of doing that will be R1. If you do the operation on the second row, guys, the cost of doing that will be R2. If you do the operation on the third row, guys, the cost of doing that will be R3. So hopefully you guys understood that you have to do operation. But what is the meaning of the operation? If you, let's say, do a operation C2, it means what will happen? You will do +1 to all the cells in column 2. That is the meaning of an operation in the question, guys. If you do the operation 2, like operation C2, this means add all the numbers in the column 2 by 1. So Ram Ram. Now guys, you only use your brain and tell me what will you do to make this 8,8 different. The same number is not allowed. Same adjacent numbers are not allowed. So what can you do? Either you can change this column or you can change this column. Let's say you try to change the column C2. If you do a C2 operation, what will happen? The new matrix will look like this. All the numbers in column 2 added by 1. 3 and 5 6 and 8 is 9. Okay, this remains as it is. Can you see the problem got partially solved? Can you see it, guys? See, 9 8 earlier the two numbers were same, now they have become different. So guys, what is the observation? The observation says that if there are two horizontal adjacent cells na, they can only be solved by doing column operation. Because see, this is a x, this is a cell x, this is a horizontal adjacent cell x. This is column I, this is column I plus 1. So if you do Ci, what will happen? All the numbers will get added by 1. So this will become x plus 1. So x plus 1 will be different from x. Or what you can do is you can add plus 1. You can add plus 1 to all the numbers in the I plus 1 row. Like plus 1 to all the numbers here. So this will become x plus 1. So x is not matching x plus 1, right? So either, when you know that, let's say you know that this is the matrix B, okay? You know that Bij is equal to Bij plus 1. So what is the solution? Either do the operation on Cj or do the operation on Cj plus 1. Which one is good, that we have to find, okay? So guys, in this case, the logic is clear that you can do either what? See, this cell is what? This cell is B32 and this cell is B33, right? B32 and B33. So all are in the third row, only horizontal matching is happening. So this is from second column, this is from third column. Either you can do C2 operation beta or you can do C3 operation. So if you do C2 operation, this matrix is coming up. This was a bad matrix because there were two adjacent cells. Now there is no problem here. But guys, still there is a problem. Earlier 5 and 6 were different. Now another adjacent cell is matching. So again, this is a bad matrix only. So you had two options. Either you do C2 operation or you do C3 operation. C2 operation is not working, guys. C2 operation is failing. Because C2 operation is making 8 8 different, 9 8. But what about 5 6? 5 6 is becoming 6 6. The adjacent equal cells are coming horizontally. Currently, we're only dealing with horizontal equal adjacent cells. Let us try C3 out. So if I do the C3 operation, what is going to happen? All the cells in the third column will be increased by 1. So 4, 7, 9, 2, 5, 8. If you do C3 operation, now see guys, no adjacent cells are matching horizontally or even vertically, baby. This has become a good matrix. So what is the solution to the problem? Answer to the question is C3. This is the minimum cost to make the matrix good. You just do the operation on this column and then all the numbers will not match. Adjacent cells will never match. C2 was also a good option, but 8 8 changes, but 6 6 becomes equal. That's why you cannot do C2, baby. So hopefully you understood this thing. So guys, in a small matrix, you understand that, what? Like if I cut all this, I hope you understand that in matrix problems, our I goes from like this, 1 to n, and our j goes from 1 to m, but here n only because it's n cross n matrix. So if there are two horizontal cells, let's try to solve only for horizontal matching cases. Horizontal case is what? Horizontal case is if you find a cell if such that Bij is equal to Bij plus 1. So this is J and this is J plus 1. Let's say they both are matching. Bond is getting created. So either do Cj operation or do Cj plus 1 operation. This is very much clear to you, my lovely student. Okay, G. Okay. Ram Ram. So now what to do? The biggest observation is that horizontal operation, like column operations can only affect the horizontal adjacent cells. Whatever column operations you are doing na, like this, they can only affect these bonds, these horizontal bonds they can affect. So basically they will surely affect the horizontal bonds which are equal, and they will change them, right? So column operation can only affect horizontal bonds, horizontal adjacent bonds. So whenever horizontal adjacent bonds are equal, you will do a column operation. Now let me take one more brilliant example for you. In this matrix, can you see, baby? What, sir? In this freaking matrix, this horizontal bond is there. This horizontal bond is there, but there is a vertical bond also. Guys, bond will always get created if there are two adjacent cells horizontally or vertically which are equal. So to solve the horizontal bond, what will you do? To solve the horizontal bond, column operation is needed when you have to solve the horizontal bond. So you have two options, right? Either do the C2 or C3. You know that C3 is best. So you will do C3. After you do C3, what will happen? So guys, after you do C3, horizontal bond has disappeared. But guys, vertical bond is still there. Can you see? This obviously, to solve the vertical bond, you need to do row operations, right? Row operations. You might have to do either R1 or R2. So either one of the six can change, right? But guys, the main observation is that first you can do all the column operation. First you can do all the column operations. Then you will do all the row operations. This is not explained in the question, but this is an observation. Why can you first do the column operations and then only the row operations? Why? Because guys, after doing the column operation, the new matrix, can you see? Whatever, here in the old matrix, there was a vertical problem of 6 and 6, right? You did a vertical operation here. It fixed the horizontal bond, but it does not affect the vertical bond. Why? If you do plus 1 to this column, what will happen? 7 to 7. The numbers will remain the same only. The adjacent number will remain the same only. So guys, what is the meaning? No matter how many column operations you do, only horizontal bonds will be broken. No effect will be happening on the vertical bonds. I am writing this here. Let us say Bij is equal to Bij plus 1. What you can do is make these two cells unequal, right? Only option is, Ram Ram, only option is either do column operation J or do column operation J plus 1. Can you see column operation J does not affect adjacent differences in vertical adjacent cells in column J. So first you can do all the required column operations, as these operations will never affect the vertical adjacent cell difference. Okay. So guys, deeply समझिए इसको. I am doing deep analysis for you. No one will do this for you. Only I am doing this. No one has that much time, love, affection and care for you like Kumar K has for you. If you are watching me in any form, you are my student. So you understand that, if you do column operations, let's say you do multiple column operations. Even after you have done multiple column operations, there will be no effect. There will be no effect on vertical bonds. Why will be there no effect? By the way, you should know that each operation can be done maximum one time. If you have done one time C1 operation, you cannot do C1 one more time. Okay, guys, can you understand? No matter how many vertical operations I do, the how many column operations I do, the vertical bonds will never be affected. For example, you can see this is a vertical bond, right? If I do a column operation here, does it affect this vertical bond? No. If I do a column operation here, does it affect this vertical bond? No. If I do a column operation here, like full column I have to select, right? If I do a column operation here, what will be the output of the last column? 7, 7, 8. Still there is a vertical bond. Bond is always there if the numbers are equal. If I do this column operation, does it affect the vertical bond? No. So guys, the answer is that whenever you do column operation, only horizontal bonds are getting affected. So what will I do? I will only do column operations and I will fix the horizontal bonds. Once this is done, then I will do the row operations. If then I do the row operations, it will fix the vertical bonds, na? So guys, column operations are independent of row operations. Get this in your head, baby. कॉलम ऑपरेशंस आर इंडिपेंडेंट ऑफ रो ऑपरेशंस. इसका मतलब क्या हुआ? इसका मतलब यह है कि तुम समझो करोड़ों कॉलम ऑपरेशन कर दो, करोड़ों कॉलम ऑपरेशन कर दो मैट्रिक्स पे, जहां करना है करो, बट जहां जहां पर वर्टिकल बॉन्ड है ना, बॉन्ड यानी ये नंबर एक्स और इसके नीचे का भी नंबर एक्स है, तो वर्टिकल बॉन्ड बन गया. जितने भी मैट्रिक्स में वर्टिकल बॉन्ड है उनको कोई इफेक्ट ही नहीं होगा तुम्हारे कॉलम में प्लस वन करने से, क्योंकि ये भी प्लस वन होगा, ये भी प्लस वन होगा बेटा. समझे? So, baby, what I'm trying to say you, bro, is that, if you do any freaking column operations on the matrix, the vertical bonds don't get affected. Only horizontal bonds get affected. This is a horizontal bond, right? So, some column operation can affect the horizontal bond. This can become 9 now. So, what will you do? You will only do column operations. Initially, what you will do? Only column operations, and you will try to solve all the horizontal bonds. Once this task is achieved, what you will do? Row operations, and you will solve all the vertical bonds. Whatever is the answer for column operation, see, whatever is the answer you got for column operation, add it with the answer you got for row operation, and the problem is solved. You can deeply analyze this. So guys, for this problem, let's first solve the horizontal bonds. Let's first solve the horizontal bonds. What is a horizontal bond? Sir, this is a horizontal bond. Horizontal bond means column operation. So either I can do, C1, C2, C3, right? This is given it to us in the form of array. Either I can do C2 or C3. C2 or C3. You know that C2 does not work, right? So I will do C3. What will happen after doing C3? Matrix looks like this. Like, let's just talk about the last guy, na? 7, 7, and 9. Now, guys, horizontal problem has been solved. If you see in this matrix, if you put 1, 2, and other numbers here, na, no horizontal bond is there. No horizontal bond is there. Now only vertical bond is there. 7, 7. The horizontal problem has been solved. Now I will solve the vertical problem. I have not written the other numbers, but you can understand, right? Vertical problem you can only solve by row operation. So guys, you can see this guy matching this guy. So either you can do row 1 or you can do row 2. So which one to do? Let's try row 1. If you do row 1, what will happen? If you do row 1, the numbers will look like 2, and this 2 will become 3, and this will become 8, and this will become 7, and this will become 9. So everything will be all right, right? If you write the other numbers also, they will look like this. So yes, you can do the row 1 operation. So one possible answer is what? One possible answer is you do C3 plus R1. C3 plus R1. You can do the row 1 operation, right? And the full matrix will be a good matrix. C3 plus R1. Another option is I can do the row 2 operation also. Now what will happen if I do the row 2 operation? Obviously this will become different, 8 and this 9, and then the other numbers 1, 2, this will become 6 and this will become 5 and then the 7 and then the 8. Yes, this is also good option. So guys, R1, R2 both are possible. C3 plus R1 is also correct answer. C3 plus R2 is also correct answer. Which answer will you print? Question is asking minimum possible. So minimum of both of them. C3 is same in both. So if R1 is smaller, the answer is C3 plus R1. If R2 is smaller, answer is C3 plus R2. So hopefully done, you got the answer. First, you will fix all the horizontal bonds and then you will fix all the vertical bonds. So guys, now let's solve an easy version of the problem. Easy version is, let's say the question was given to you and they told that only solve the horizontal bonds. Only solve the horizontal bonds. You don't care about the vertical bonds. You don't care about the vertical bonds. You don't freaking care about the vertical bonds. Always respect your mother and father. Always respect them. Listen to them. Now, so guys, Indian parents care a lot for you. So please do the hard work needed in your life. Please full focus, attention, energy in your own self, not outside, in your own self. Ram Ram. So you don't care about the vertical bonds, only need to solve the horizontal bonds. So we can use a dynamic programming. We will make a array dp of n. Dp of I will say tell you that minimum cost to solve till column I. To solve the matrix till column I. That's it. So let me take a small part of a matrix to explain you the answer. There are many columns like this. Okay, one, two, three, like this. So what is the meaning of dp of 1? dp of 1 means what is the minimum cost to solve this part of the matrix. What is the minimum cost to solve this part of the matrix? Generally zero, right? Generally zero, right? Because you don't have to do any operation, right? But guys, how will we know that if we have selected this column or not? So let's make an advanced state. dp11 and dp10. You got the meaning, guys? What is the meaning of dp11? dp11, first is the index I. So dp11 means what is the best answer to solve this much part. This is the full matrix, first column of the matrix. What is the cost to solve this, guys? If you are doing operation here, this means yes, you are doing operation on this. So if you do the operation, how will it look like? 2, 3, 4. But you are not considering anything adjacent. Now in one column, there is nothing adjacent on the horizontal. We are only trying to solve horizontal bonds, baby. So nothing on the adjacent. So problem is solved. So what will be dp11? dp11 means best answer to solve the first column. Best answer to solve the first column. If you are doing the operation on the first column, the answer will be C1 na. You are C1 is the cost of doing operation here. Yeah, you are saying the best way to solve it such that you are forcefully adding 1 to all the numbers in this column. Then it will take C1 rupees to do that na. So dp11 is C1. But guys, what is the best way to solve the first column if you are doing no operation? You are doing no operation. 1 remains as it is, 2 remains as it is, 3 remains as it is. No operation, 0 rupees. So guys, dp11 you have solved it, beta. dp10 you have solved it. Now let's try to solve dp20. dp20 means best way to solve this two columns. Best way to make sure that the two columns are solved and there is no horizontal bonds in the two columns. Best way to solve the first two columns such that there are no horizontal bonds and no operation is done on column 2. This 0 means no operation should be done on column 2. So guys, you are forced to do no operation on column 2. So what is one possibility? One possibility is that you don't do any operation on the first column also, and you don't do any operation on the second column also. So what will happen if you don't do any operation on the first column as well as the second column? The numbers will be what? You don't do any operation here, na? Done, 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 done. You don't do any operation here, right? Is there any horizontal bond? No. No horizontal numbers are matching. So yes, guys, this is a good matrix. I am saying for DP20 means best way to solve two columns such that on column 2 you are doing no operation. So yes, see, in column 2 I am doing no operation, but I have to decide now what can happen on column 1. So let's assume one case where I don't do any operation on column 1 also. So what will be the answer for DP20 in this case? I did no operation here, 0 rupees. I did no operation here, 0 rupees. And this is a good matrix, no problem. So DP20 is 0. For DP20, what you will do, you will travel the first column and this column one more time, and you will see, as you are doing no operation, no two horizontal numbers should be matching. As no two horizontal numbers are matching, this is a good matrix. So the minimum cost to make the good matrix is 0 rupees. You don't have to do any change. No horizontal lines are matching, baby. But guys, what if the matrix was different? Then what would you do? DP20. Guys, what is one possibility? In DP20, there are two possibilities. DP20 means best way to solve the two columns such that on column 2 you are doing no operation. So on column 2 you might do no operation, on column 1 you might do no operation. And another possibility is on column 1 you might do some operation and on column 2 you are not doing any operation. Okay. So guys, for this matrix, will this work? Let's see. Let's try to do no operation on both the columns. I have done nothing on first column, I have done nothing on second column. But there is a bond getting created, horizontal bond, and you don't want this bond. You have failed. Answer will be infinity. Why the answer is infinity? For if you don't do any operation on the first column and if you don't do any operation on the second column, you cannot avoid the horizontal bond. You want the best answer such that you don't do any operation here, don't do any operation here, then also it is a good matrix. But this is not possible because this time 3 3 is coming. If you don't do any operation, it will not be a good matrix. So when it is not a good matrix, you answer it as infinity, means infinite cost. Not possible, infinite cost. So this case will give infinite cost. Other possibility is DP20 means best answer to solve this matrix such that you don't do any operation here, but you are allowed to do operation here. So guys, if you do operation on the first column, can you imagine hypothetically how these numbers would look like? This would be 2, this would be 3, and this would be 4, because you are doing plus 1 operation on first column and second column no operation. Now check. So guys, did you understand? You for DP20 there are two possibilities. What are the two possibilities, baby? The two possibilities are that, second column should not be done, that is fixed. Either you do the first column or you don't do the first column. So if in this case, if I don't do the first column, answer is not possible, infinity. If I do the first column, what I can do is, for DP20 calculation, what I can do is I can just travel these two numbers now. Like I can just travel the column 1 and column 2 like this, and I can check if I add plus 1 to all these numbers, Is there any bond getting created? If no bond is getting created, it means it is a good matrix, problem is solved. So if I go to the right case where I don't do any where I do the operation on, like I don't do any operation on the second column, but I do operation on the first column, it looks like this: 2 3 4 and 3 4 3. See, no bond is getting, horizontal bond is getting created. So yes, the answer is possible. This is a good matrix. So what will be the cost to do this? You are doing no operation on second column. So for second column, 0 rupees. But you are doing operation on the first column. What is the minimum cost to do the operation on the first column? It is dp1 of 1, which we calculated earlier. You are doing operation here now, so the minimum cost for the first, to solve the first row, if you are doing operation here, is dp1 of 1. So the formula dp20 for this particular case will be dp1 of 1 plus 0. So the best way to solve the first row with plus 1 operation plus 0 is dp20. So you understand, for dp20 there are two cases. Like this, you can solve for any index I. dpi0 will only have two cases. On column I minus 1 you do nothing, and on column I you do nothing. Or on column I minus 1 you do something, and on column I you do nothing. Why in both the cases on column I am doing nothing? Because dpi0 means that forcefully you should not do any operation on column I, baby, bro, baby. Okay. Now let's calculate dp21. dp21 is a totally different ball game. dp21 means, let's say this was the matrix. Okay, I'm changing it again and again to, so I can show. Best answer to solve the first two columns. You have to solve n columns, right? So final answer will be what? dpn0 or dpn1, whichever is minimum in them, because you want the minimum cost. dpn0 means best way to solve the n columns such that no operation was done on the last column, or best way to solve n columns such that forcefully an operation was done on the last column. Okay. So what is dp21? dp21 dp21, okay, best way to solve this such that the operation is done on the second column. So guys, again there are two options. On column 2 you will do operation on, in both the cases you will do operation on column 2, but one option is you don't do any operation on column 1. One option is you do operation on column 1 as well as column 2. So minimum of both the cases will be the answer. So let's try the first case. I don't do any operation on the first column. So how will my matrix look like? First column will look like that only, and the second column 2 3 4. Is this good? Just check, is this good? Yes, no horizontal bond is coming. So yes, this is a valid case. What will be the answer for this? The answer for this is, you are doing the option on the second column, right? So C2 is the cost to do the operation on the second column. On the first column, I did nothing. So what is the best way to solve the first column if I do nothing? dp10. So dp10 plus C2. So which is like dp10 is nothing but 0 only. So 0 plus C2, C2. Okay. So dp10 plus C2, one option. Now what about the second case? What if I do operations on both of them? This will look like 2 3 4. This will also look like 2 3 4. Guys, the horizontal bonds are coming. Not even a single horizontal bond is allowed if you want everything till column 2 to be satisfied. So for this case, the answer is infinity. For this case, the answer is dp10 plus C2. So what you will do, you will take minimum of this case and infinity, and that is the answer for dp21. So guys, dp20, dp21 calculated like this, you will do for all the i's. You have to calculate till n, right? So for I means best answer to solve all the columns from 1 to I. dp of I means best way to solve for all the columns from 1 to I such that there is no horizontal bond anywhere in this part of the matrix. And if I write here 0 means, if I write here 1 means, The best answer only, but forcefully the operation was done on column I. We need to maintain the track now if you're doing the operation or not. And DPI 0 means DPI 0 means the best answer till here, but operation was not done on ith column. So DPN 0, DPN1, two options, minimum of them will be the answer. Whenever you are at I, what will you do? You only need to check this column and I minus one column. For 0 case, there will be 2, right? 0, 0 and 1, 0. For 1 case, there will be 2, right? 1, 1 and 0, 1. Calculate minimum of both of them. Whenever 1, 1 case, imagine you have added one number here and 0 number here, depending on what case you are doing. If it is 0 comma 1, imagine you are adding 1 to all the numbers to this column and 0 to all. After doing this, no horizontal bond should be there. If there is a horizontal bond, you have failed, baby. So guys, finally, for any particular matrix, to solve all the horizontal bonds, what will you do? To solve all the horizontal bonds, you will do column operations. You will solve it by DP on dynamic programming on matrix. There will be two options, DPN0 or DPN1. You will take the minimum of them, okay? Minimum of both of them, and that will solve the whole problem, okay? That will just solve the whole problem for you. So this thing is very much clear to you. Wow, 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 wow. But guys, what about the vertical bonds? I told you, no matter how many column operations do, it does not affect the vertical bonds. Now I will do another DP to solve all the vertical bonds. So guys, for the vertical bonds, what you have to do? Row operations you have to do, right? R1, R2, R3, R4 till R5, like N, right? So now the DP matrix will be like this. DP1, DP2, okay. DP2 means best way to solve the two rows. Best way to solve two rows. DP2 1 means DP2 0, you understand now? Best way to solve the two rows such that there is no vertical bond in them, because now we are solving the vertical bonds. Horizontal bonds are independent from vertical bonds because column operations don't affect the vertical bonds, and row operations don't affect the horizontal bonds. So like this, guys, you calculate answer for this also. So answer for this part plus answer for this part. To make things easy, you know what I did? I just rotated the matrix to the right by 90 degree. For example, first I have to solve all the horizontal bonds, right? Horizontal bonds means, let's say these two numbers were same, so I have to solve this, right? So I will do my DP algorithm on this, but later on I have to solve the vertical bonds also, right? So I will just rotate this matrix by 90 degree. So if I rotate this by 90 degree, it will look like 7 4 1 2 3 7 4 1, then 8 5 2, then 9 6 3. See, 1 4 earlier it was looking vertical. Now 1 4 bond is horizontal looking like. So you can apply the same DP algorithm without changing row and column. First solve this problem, get the answer, then rotate this matrix to right by 90 degree and apply the same algorithm for columns only, because now the columns have become rows. So this is interchangeable, like transpose of matrix. You must have understood it, baby. Now you're Kumar case student, you can do it. So easy version is given a matrix. Just make sure no two horizontal adjacent cells should have the same value. Once you solve it, make sure no two vertical adjacent cells have the same value. Add answer for both the cases as they are independent. You can do it without transpose also if you are interested in making 2 DP arrays. Let us make use DP to make sure no two horizontal adjacent cells are matching. Okay, so DPI 0 best minimum answer to make sure all columns till I are good. Good means in these columns there should be no adjacent horizontal cells matching. Okay, but you will not do operation on column J. Okay, DPI1 means best minimum answer to make sure all columns till I are good. Good means in these columns no adjacent horizontal cells match. Okay, but you will do operation on column J. Okay, sorry, on column I. Final answer will be minimum of dp n1 dp n0, and you can rotate matrix to right by 90 degrees. Okay, do the same algorithm and you get the final answer. Like, I will show you the code also. This code really works, trust me, it's the best possible code. Like, you see, you have taken the input of the matrix, guys, see, taken, then the, cost array of for columns, for rows, and the cost array for columns. I have written a function which will do the dp algorithm to calculate the cost. So if I go to the compute cost section, you can see DP10, na, to solve the first column without any operation, 0 rupees. If you do operation, then C5 of 1, which is the C1 basically. C5 is the column array, okay, of cost. Column array of cost. C5 of 1 means cost to do operation on column number 1. So guys, now I will go through all the columns from 2 to n, right? And guys, I will just check. See, DPJ0, two cases are there. J minus 1 remains 0 or this remains 0. If both remain 0, nothing should match. If it's matching, there's a problem. Or the previous one was done plus 1 operation and this 0 operation. And then guys, dpj1, either 1, j minus 1 was 1 and you were 1, and either the previous one 0 4. So 4 cases all solved, all done, problem solved. And then I rotate the matrix by 90 degrees. Once I rotate the matrix by 90 degrees, I put the values in my B matrix, and I also reverse the C array. This is given up to the reader for the homework, okay? Like C matrix को मुझे C को C रो वाली जो रो वाला ये जो तुम्हारा ये है ना, R1 R2 R3, जब तुम रोटेट करते हो तो मालूम है क्या हो जाता है, ये ना R3 R2 R1 हो जाता है, ये एरे उल्टा हो जाता है, देख रहे हो, रो का एरे जो कॉस्ट का था, तो इसको रिवर्स करना पड़ेगा ताकि ये फिर से उल्टा दिखे अपन को, R1 R2 R3 ऐसे, ठीक है, just to keep things safe, okay, or else it will start calculating wrong costs, that's why. ये इसको फर्स्ट समझेगा, उसको वो समझेगा, तो थोड़ा सा है मैनिपुलेशन, बट इट्स ओके, राइट? डीप एनालिसिस करोगे समझ जाओगे बेटा. If the cost is greater than 10 raised to 18, like 10 raised to 18 is our infinity, then minus 1, else this. So hopefully you understood it. Ram Ram. Love you all.